Apologies for what happened earlier. It was an issue of a network, and of course, we could not continue because you could not see anything. Now we are going to record this lesson, and hopefully, you will get a thing or two. Please don't mind the sound on the side. There is a sound that usually comes out beaming there. I think it's the battery. We do have an issue of electricity this side, so that battery is converting the sun is converting energy from the sun to this device that I'm using, so it is that sound, so please don't mind it. Thank you. Of course, let's start with what we did last time. We talked about ungrouped data, and we said ungrouped data is data presented as individual observations without putting them into groups, categories, or classes. So when you have data and every single observation is written just like this age is here, someone of 18 years, the other is 19 years, the other is 19, the other is 20, the other is 21, 21, 22, 24. It is written like this. It is ungrouped data. Versus when someone is saying how many people are between the age of 18 and 19, something of that nature, that is not ungrouped, because now you are not listing everything. When everything is listed as it is, that is ungrouped data. When people are listed as they are, instead of saying I have how many black people are here, and then you say 5, how many white people are here, how many Indian, how many, that is not ungrouped. Ungrouped is saying this is black, this is black, this is black, this is white, this is white, this is Indian, this is, so every single thing is listed in ungrouped data. And we made the test score as examples, of course, and said if we have test scores listed just like this as they are, that is also ungrouped data, because everything is listed separately. And when it comes now to grouped data is something of this nature. The age between 18 and 20, there are 4 of them. Between 21 and 23, there are 3 of them. Between 24 and 26, there are 2 of them. Between this and that, there are this. So this one, they are grouped according to age groups, so it is grouped data. But when you look at this one here, everything is listed individually, then that is actually ungrouped data. I hope you can see the difference. That grouped data is data that has been organized into groups or intervals, usually with the number of observations in each group. That is grouped data. I hope you can see the difference here. And now the other part that we touched, it was arithmetic mean. The measure of central tendency is one of the arithmetic mean. It's actually looking at the center. Is actually understanding the center of the given data. Arithmetic, the word arithmetic is not it's just telling us how to calculate the mean. So when I'm saying arithmetic mean, I actually still mean the mean. Without the arithmetic or the average, is still one and the same thing. Mean, arithmetic mean, average is just one and the same thing. Now, what is the arithmetic mean? If I place all the numbers as equal weights on a beam along a number line, the point at which the beam will balance is the mean. What does that supposed to mean? What this means, suppose I have observations. Let's say the observations are, I have 4, 3, I have 4, I have 3, I have, let me just make an example here. Maybe this is gonna make perfect sense. Let me add a page at the end, page at the end. Just these 2 pages. Suppose that I have numbers. I have 1, I have 2, I have 3, I have 4, I have 100. Right. Now, suppose I had a number line. This is my number line. I have 1. The number line, usually, you know the number line. It moves from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 100. Here I have 100. Right. And then here I have 1. Of course, here I will have a 2. And then here I will have a 3. Here I have a 4. These are my data points. I'm trying to explain here what is the mean and what it actually means. Okay. Now, suppose that this is a plank, right? It is a plank. It is this part of the beam. It is this part of the beam balance, right? Okay. Now that I have these numbers as they are, now I want to, where's this now? I want to place, okay, I want to place this rod here. I want to place this rod in this thing so that it balance. What do we mean by balancing it? I want to pick a point somewhere. Is this point close to this side, or is it point close to that side, such that when I place this rod here, this whole thing will balance. It's not going to fall this side, or it's not going to fall that side. The weight on this side is not going to be too much compared to that, and also the weight this side will also be equal to that side. Now, what is this weight that are we talking about? Now, if I look at this 4, the distance, I want, when I take the distance from this 4 to that point, the distance from this 3 to that point, the distance from this 2 to that point, and the distance from 1 to that point. If I sum all these distances, they're supposed to be equal to the distance from this point to that point. That is the idea of the mean. So I take these things, I place them in a number line. And then after placing them in a number line, I want, if I sum all the distances from each of these data to that point on the left, it must be equal to the distance from that point to all the points on the right. I hope this makes sense. Let me make an example here. If you look at the distance from 4, okay, let's first assume this value here, it is 22. This value is 22. Let's suppose that it is 22. Now, if I say 22 minus 4, I will get this distance here, which is 18. So I have an 18 here, which is the first distance. And then I look at 22 minus 3, that is a 19. Right. And then I look at the other one, I have a 22, and then I subtract a 2, I have a 20 there. And then the other one is 22 minus 1, I have a 20 there. The other one is 22 minus 1 is going to be a 21. So the distance from 1 to that point, the distance from that to that point, and the distance, they are given like this. Now, what is the distance between 100 and 22? Let me calculate it. Then here, I will have 100 minus 22. That is 78. That is 78. Now, the question is this point the equal sharing point, or the point where this beam will balance, not fall this side or that side? When I am summing these values here, when I am adding 18 plus 19 plus 20 plus 21, what am I getting? I have an 18, I have a 19, I have a 20 plus a 21. What am I getting? I get a 78. So the mean, or the arithmetic mean, or the average of this data here, it is 22. Why? Because it is an equal sharing point. The distance, the sum of the distances of all the data on the left, it is the same as the sum of the distances from this point to all the data points on the right. That is actually the mean. I hope I'm making sense here. That is the first way of looking into the mean. It is that point whereby the distances, when I'm summing the distances from the left and the distances on the right, I get equal values. In other words, my beam will balance. That is the first one. The second way to look into it, if let's say I were to put equal weights, let's say here I put a weight of, let's say 10, 10, 10, 10, 10, 10, 10, right, on this number line. What is the point whereby I will put this rod here such that the weight on this side and the weight on this side is the same? That is actually the mean. I hope I've explained it and now it makes sense. I'm hoping. If you're not getting it, please ask the rep. The rep who's supposed to know it. I mean, we choose you to be the rep so that you may know things, so that when we ask you, you know them. And also, of course, the tutors, they can help you with that. So if I place all the numbers as equal weights on a beam along the number line, the point at which the beam would balance is the mean. That this point here, whereby the things on this side and that side will actually balance, it is the mean. That central tendency, that point that balances thing, it is the point. It is not necessarily on the data. It is just telling us more about the center of the data. Does it make sense? I hope so. If I were to put all these as equal weights, would my beam actually balance? I have a number line, place a weight on number one. For example, in this example here, this is number 1, 2 up to 100. I place here a weight, maybe 10. I place another one here. I place another one here. I place another one there, and then I place another weight here at 100. Now I place equal weights. This is the second example. I'm hoping it's gonna make this perfect sense. Now this is my ruler or my number line, and here is 1, 2, 3, 4, 5, and so forth. This is the data, and then of course here I have 100. I have 100 here. I have 100 there. Here I have a 2. Please don't mind that noise. It is this battery is starting to do its thing. I think it does this when it's cooling off. I think so. So we have 3 here. We have 4. Remember our data, it was 1, 2, 3, 4, and then we had 100. That was our data. Now, what is the mean? I want to explain this mean, maybe you will get it. Suppose I place bricks here that have equal weight. There is a brick that is here. I'm just making an example here, guys. Each brick is 2 kilograms, 2 kg. I place another one here. At 1, I place a brick of 10 grams or 10 kilograms, whatever. But this brick and this brick and this brick, they have the same weight. Oh, I place 1 kg of sugar. All of you actually drink. I think all of you knows someone who's drinking tea, or you are drinking tea with sugar. Suppose this one have is 1 kg, 1 kg, 1 kg, 1 kg, and I also here at 100 I place 1 kg. Now the question is, what is the mean? The mean is saying, where can I put my rod? This one is the rod, right? This is what I call the rod, right? Now, where can I put this thing here so that this side does not fall and also this side does not fall? Should I put it here, or should I put it here, or should I put it here, or should I put somewhere? So that is the idea of the mean. Where can I put this rod so that this thing would balance. This whole thing would balance. Given that this weight and this weight and this weight and this weight, they are the same and also the same as this one. If this one was 10 kgs, this one is also 10 kg, this one is also 10 kg, this one is also 10 kg, this one is also 10 kg. Now the question is, what is the mean? When I'm asking you what is the mean, I am asking you, where can I put this rod here such that the weight on this side actually balances the weight on the other side? Should I place it here? Will it not fall? Should I place it here or should I place it there? Where can I put it? Now at number 22, as we have seen in this example here, at number 22 on the number line is where these things will actually balance. Even though here this side I will have 10, 20, 40 kgs and this side I had 10 kgs, this is the point whereby this beam will balance. I think this makes sense now. So you can either think of this as the distances from that point, or think of placing equal weights on these values. At these values you place a weight, at these values you place a weight, place a weight, place a weight, place a weight, equal weights, whether it's 10 or 20 or 5. Then where would I have to put this rod here such that the beam balance like this? So that is the meaning of the arithmetic mean or the mean. I hope it makes sense now. Now to calculate it, simple. First you need to understand what is this x bar is. We have to understand the notation. So this x bar here is actually the mean of the sample. A sample, of course, is a portion of the population, and this mu here, it is actually what this mu here, it is actually the mean of the population, the entire group that you are studying. And to calculate the mean, you take the sum of every single observation. You add all these observations, you sum them up, you add them, you get the total. If I were to sum them, what is the total? And then you divide, you count them. The number that goes in the denominator, you count them, how many of these things, and then you will be able to get the mean. And of course, mathematically we'll write it like this or like this, where this is x bar, the sample mean, this is the number of observations, this is the total or the sum of these observations. This symbol here is a sigma notation, which is telling you sum these things up. This is telling you this, I'm in observation number I, I'm in observation 2 or in observation 3, but having this sum is saying sum all these up. I hope you get this thing, that this one is just the total, take the total, and then this one, how many of these observations. Okay. Before we do or calculate this, let me just deal with this example here. There's this example that I was doing on the side here, 1, 2, 3, 4 and 11. Let's just do it right away. So first I have to sum them up to find the mean. 1 plus 2 plus 3 plus a 4 plus 100, and then divide by how many of these things. 1, 2, 3, 4, 5. We have 5 of them. Then you get your mean. So this is the point whereby I can put my rod. That's where I got this 22. This is the point whereby I will put my rod such that these 10 kgs, when they're placed in these numbers, that's where I will be able to balance my beam. That's where this data is actually balanced. That's where each of these points from the left have equal distance from that point compared to the points on the right. I hope this makes sense. Of course, let's look at the questions, of course, on how to calculate arithmetic mean of ungrouped data. In other words, when every single observation is listed down, how do we calculate the arithmetic mean? Suppose that this is a question: the scores of 6 students in a test are 55, 60, 65, 70, 75, 85. These are the scores. Calculate the arithmetic mean, or calculate the average score, test score. Calculate the mean score. So that will be the question. I said if you want to calculate the mean, first sum all of them up, add all these numbers that are given, then count how many of them, and then you divide by that number. Whatever you are getting, it is supposed to be your answer. Let me do this one, the first one. I'm gonna do the first one and the fourth one, and then the other ones you can do them at home. I'm just gonna explain just few things, that's why I'm doing this. The first one is going to be sum them up. I will have 55 plus, and then I have 60 plus I have 65 plus I have 70 plus I have 75 plus I have 85 divided how many of these things that we have, how many of these points, how many of these observations. I have 1 2 3 4 5 6. I have 6 of them. Now is 205 divided by 3, or 6.68.33. I mean 3 bar, and 3 bar means 3 3 3 3 3 3 3 3. This 3 keeps repeating. But when you are writing this and no one have said round it up or round it off, and you have that desire to round off, always round off to 2 decimal points. Of course, even when you are dealing with money, you know that when you are dealing with money, cents have 2 digits, of course, so you always round up to 2 decimal points, or 2 decimal up to 2 decimal places. Yes, 2 decimal places. 2 decimal means 2 numbers after the decimal point. 1 decimal means 1 number after the decimal point. Here, if I take these 2, first I have to check the third one. If it is big, if it's bigger than 4, then I have to add here to round off. If it is less than 4, I just take this as it is. So this one here is going to be 68.33. That is actually the average score, or the arithmetic mean of these test scores. I hope I'm making sense here, that you just take this, divide by that, so this is going to be an average, or the arithmetic mean. Let's also do this one here. This one here is going to be, I have a 20, and then plus 25, and then I have a 30, and then I have a 35, and then I have a 40, and then I have a 50. And then how many of these things? I have 1 2 3 4 5 6. I have 6 of these things. Then my mean is going to be 100 divided by 3, or 33.33, or 3.33333, and then you continue until the end, because when you have a bar, it means that you continue, just that the digits of this calculator ends here. It does not continue. If it had time, it was going to continue. It had space, it was going to continue. But now this average here, the question was, a business had the following number of customers over 6 days, 20 days. Calculate the mean number of customers per day. This is what I usually say. You cannot say I had half a customer. Even if someone is too short, you cannot say it's he or she is half a person. A person is complete, a customer is complete. You cannot have 33.33 customers. Either you have 33 customers or you have 34 customers. That's about it. You cannot have a comma something. Human beings or animals or those things, organisms, is either you have the whole thing or you don't have it. You cannot say I have half a human being. I hope you understand what I'm meaning by that. So when we are calculating this, we're supposed to say to round it off to the nearest whole number, because 3 is less than a 5, so we have 33 customers per day. That is the average. I hope I'm making sense here. Pause this video here and then try and solve other questions there. Just pause it. Yeah. Now that you have done it, calculate these other problems, and when you are done, you can check the solutions, which are just here. as you can see here, I summed them up and then I got this, and then even here I summed them up, I got that, and then I summed this and then I got that, and then I summed this, I got that. And this 33 is what I was saying, that when you are dealing with customers, you cannot say I have half a customer. You either have a customer or you don't have a customer. Hence I rounded it off. And rounding it off, you know that if I want to round off to the nearest whole number, I check the number, the first number after the decimal point. If it's less than 5, then I don't add anything, I take this 33. If this was 5 or 6 or 7 or 8 or 9, then I was going to add 1 here, so that I will end up having a 34. I hope that makes sense to you. Rounding it off, you just look at the next number. Is this number bigger than or equal to 5? If it is, you add the number, add 1 to the previous number. That's what we do. Okay. Now the question would be now, why would you spend time focusing and trying to understand and calculating the mean or the averages, knowing very well that you are an auditor or you are just someone who is busy studying a very busy career, a very important career, and now you are studying this mean here? Why? Should you stop it or should you continue? Why is this mean actually useful? So the mean or the averages, they are very useful when you are trying to understand and summarize financial information. Usually, auditors, they often deal with large amounts of numbers. I want to explain this a little bit because it actually affects all of you. As an auditor, most of the time you will be trying to explain to the owner what is actually happening to this expense column. Now, if you are trying to explain expenses every single month, you will understand that most of the time owners or managers or CEO or whatever, they usually don't have time to sit down maybe hours and hours. You listing every single number that, okay, look, we had this expense in 2023 January we had this, in February we had this, and then in 2024 January, February, March, April we had this and this. They don't have that time. Now, what they want to get, they want you to give them a representative figure, one representative figure that actually, on average, you did all these calculations, that you collected all the expenses, and then you just found the average. You added all these expenses, and then after adding them, you found out how many expenses did you have. You divided, and then you found the mean. Now that you have that mean, it is what you can use to explain how these expenses are. If relatively, what can you say about these expenses? On average, say, we are actually having this monthly expense. Instead of listing every single thing, you can tell them. Can you see that in 1 minute or 2 minutes, you have explained what is actually happening with their expenses, with their company expenses? So that is how arithmetic mean can actually be used to summarize long and big data of financial information about expenses. So instead of examining 12 separate monthly expenses, you can calculate the average monthly expense and then say that on average, this is how much we are spending every single month. I hope this makes sense. The second reason is you want to identify unusual financial figures. Let's say you had this company for a couple of months now, or maybe years, and you have been collecting expenses, right? You always spend this much, and let's say on average you find out that, okay, I usually spend on average 50,000 per month. When you start to spot in 1 month the total expenses going to 150, then your mind is actually going to start to be alarmed out, why did we spend this much? And now you can start to think of what is the main reason for this, and then you can start investigating what are the reasons and what actually made this expense to be this much. And then you can actually come to your conclusion that, okay, maybe we bought this Maybe someone is stealing money in the company by just knowing this arithmetic mean. That means you have been finding these averages, so forth, and now you know that per month I usually don't go way above this 50,000. Why now am I this 150,000? So you end up investigating further because of an understanding of arithmetic mean, unusual financial figures. Or maybe, why this month did we just spend 5,000? We usually spend around 50,000. Why 5,000? Are these people not doing their work? You start getting cautious of what might be happening inside the company, or what might be happening inside your program, or whatever you are dealing with. That is another reason for arithmetic mean. The third one, I like this one because it affects everyone, including myself. When you want to budget, if let's say you are budgeting, right? You are budgeting. You cannot just say, this month, because you are on NSFAS, what I'm gonna do, I'm just gonna say this month I'm just gonna buy a cardboard of bananas, and then each day I'm just gonna eat 2 or 3. I want that iPhone, I want that thing, I wanted to buy that t-shirt for my person, I wanted to do that head, whatever you might be thinking of budgeting along. What the real budget actually is all about. Not just say, only this month I'm not gonna eat that. Most of the time people are lying. You find someone going to the neighbor, can you help me with this? Because the budget was not realistic. Here I'm talking about the realistic budget. When you want to budget, the first thing you do, you bring out your bank statement, you close the door, you shut it off, and then you look in January, what did I buy? You list them down with this much. I bought a chippies, it was this much. I bought a pen, it was this much. I bought a pizza, it was this much. I did nails, this much. I bought a body lotion, this much. Everything that you actually did. And then you write the total of January. This is how much that I actually spent. I spent this much, and then you go to February, and then you list everything, and then you find the total, you list it down. You go to March, you go to April and May, and then you have all these numbers. Just for example purposes, suppose that in January you had 8,000, in February you had 9,000, and then the next month you had this, and then you had that, and then you had that. Now, what an average is going to help you with, let's say I have this 8. You know how to calculate averages. I have 8,000 plus I have 9,000 plus I have 8,500. Not 85,000. Delete that. And then you also had 10,000. We had 10,000 with 1,000. And then what else do we have? Plus 9,500. 9,500. And how many of these observations that I have? 1, 2, 3, 4, 5. So I have 5 of these things. And now the average is going to be 9,000. Now this average is going to help you to determine that, okay, on average each month I am spending around 9,000. Now if let's say you are earning 15,000, just like you do on your NSFAS, you can say, okay, each and every month that I'm having this much, I'm spending this much. Then at least now, to invest in my shares or in my unit trusts or in my ETFs or in properties, I know how much remains each and every month. I am spending roughly around 9 months every month. Now you can say that for food, or you can say personal expenses, and then you place that 9,000 there. And then you can go now on emergency funds, you have this, and then you go on other things. This is how you determine the amount of money that you spend. So it helps you to give you a starting point, the point where you can start preparing your budget, this 9,000. Let's look into it. What is it going to do for you? Suppose that you had this, and now you are in January and you end up spending this 8,000. If you spend 8,000, you can start saying, okay, the 1,000 that remains, I'll put it in emergency funds so that when I get an emergency, I can use that 1,000. When it comes to February, you have this 9,000. Of course, I'm always allocating 9,000 per month to spend, so it goes there. As it is, nothing remains, nothing is short. And then when you go to March, you have 8,500, and then 500 goes to emergency funds, and then you spend this. And now you can see that in your emergency funds, now you have 1.5 that is there. And then the following month, when you start to spend 10,000, you go to your emergency funds, you add the 1,000 in this 9,000, and then now you have the 10,000 to spend. Can you see this? And when you go to this month here, 9.5 that you have to spend, you go to that remaining 500 and then you put it there and then you are happy. Can you see that you have minimized the debts, you have minimized the things? And you can even see that if you really want to have more money on investments, you can actually try and reduce this average by reducing monthly expenses. At least it gives you a starting point of where to start to budget. It gives you an overview of how your monthly expenses are. It gives you the idea of, is this usual or not usual to get this high value or this small value. That is what the arithmetic mean actually helps you with. There's other examples here. It helps you to make informed decisions about loan repayments. Let's make an example that you are in sales. You are selling something, and now that you are selling something, in 1 month you make 15,000, the other month 17,000, the other month 16,000, the other month 18,000, the other month you have 14,000, and then your salary or your income is fluctuating, is not sitting in one value. By taking or finding the arithmetic mean or the average, and when you're using your calculator, of course, you will end up finding this assistant. Let me not be lazy. Let me calculate it. Let's say you have 15,000. There was your 15,000 plus, and then you have your 17,000. 1, 2, 3, and then you have your 16,000. You have your 16,000 here, and then you also have your 18,000. 18, 1, 2, 3, and then you have your 14,000 plus you have your 14, 1, 2, 3. 14,000, and then you have your 16,000. You have your 16, 1, 2, 3, and then how many of these things? I have 1, 2, 3, 4, 5, 6. So I have 6 of these things. Now the average is 16,000. What does this mean? If let's say you're making this money is actually giving you a reference point of, okay, how much can I afford, because I'm making on average this amount of money. Now, how much can I afford to actually pay on a loan? Of course, there are other factors that you have to look. You have to look at the month whereby you're making the lowest income, but at least the average is giving you an idea of what is your monthly salary. So that is what the arithmetic mean actually helps you to determine if will you be able to pay this loan, or should you need to negotiate for them to reduce the monthly payment. Because most people, they always assume that I need to pay more so that I can finish sooner. Sometimes you just can't. So the average is actually helping you to actually think in terms of how can I how much can I actually afford. I hope you understand this. Very well. Okay. That is another one. Another example is, if let's say you have 2 businesses, it's either those businesses are yours or you are helping someone who have 2 businesses to make an informed decision or to actually determine the performance of each of these 2 businesses. Right? You look at this business, you look at their sales. Let's say you look at the sales. Yeah, most people, they just think just because this month I've made 300,000 and the other company made 50,000, I'm performing better than them. That's not always the case, because it might happen that last month they made maybe 500,000 and I made 300,000. And when you keep checking and tracking all these companies, you find out at some month I was beaten, and the other month let's say I have to have two companies, company A and company B. You find out that in 1 month the company A is beating company B, in other month the company B is beating company A, and all these companies, you just want to find on overall that which one is actually performing better than the other. So the average is by just finding the mean on the other sales of the company, of company A, and find the mean of the other company. You will be able to tell which one is actually performing better than the other. So you will be able to compare them by using their average monthly sales based on using the mean. I hope that makes sense. You cannot just look at this month now they made. You have to track their performance. I mean, in the previous month, how they have been performing until now. Hence, other companies, you find out that they look at yearly income, not just months, because 1 month doesn't mean anything. Things differs. So to track it, maybe others, they say, okay, I'm going to track for 5 years which one is actually doing well compared to the other. Most of the time when you have two companies, you'll find out that you have the third thing that you are doing using the income of these companies. So you want to track which one is performing better so that you can focus your efforts on the other company that is performing well, or you need to pay attention to this one that is not performing well because it might be sinking, something of that nature, so that you end up making informed decision based on this arithmetic mean. Another example would be you want to test the performance of a department or the performance of employees. How are they doing? Let's say we are checking the accounting department, and you see that in the first month they processed about 400 invoices. The second one they processed about 450 invoices, 500 invoices, 330, and these invoices over 5 months. And now, when you look at this average, you can determine how much each employee actually get. Like when you get the average, you'll find out actually on average, this is the amount of invoices that we're processing. Is this number of invoices suitable for this number of employees that I have? So the average is going to tell you that, it's either these invoices, they are too much for the kind of employees that we have. Should you add? You will understand if I should add. Or maybe these employees, that is why they always knock off early, is because we are having too many employees for these invoices. So you can end up deciding, okay, let me release some of these employees, or let me add more of these employees based on this arithmetic mean. That is some of the reasons why I study arithmetic mean. Another one is when you want to purchase. Let's say maybe this year you are about to change your supplier. You're about to change your supplier, and then the following year you want to find the one that is suitable for your deal. And then starting in January, you decide, I'm going to record their prices, the prices of the people that you know sell this thing that you want. And then you keep recording their prices, including their promotions, every single month. And then once you find the average per year, that this supplier have the lowest average, you know that in total they have the lowest price per year. So it makes sense for you to go and seek a contract with them. I know most people, they always think that, why can't I just each and every time I have to buy, go and look for the lowest price that is out there. In most cases that can be done, but sometimes when you are dealing with so many large accounts, large things, for like the employees that you have, you don't have so many employees, so you want an employee that will be doing so many things. You don't want one employee to be assigned to purchasing. You want an employee that will be purchasing and also delivering things and also doing some other things within the company. So to minimize the work that have to be done, you might think of, okay, the best way is to just pick one supplier that have the lowest prices in a year. That is where the averages might actually help you to determine, oh, this one is actually charging less compared to the other one. I hope this makes sense. That the averages can also tell you that you have been performing like this for the past couple of months or for the past couple of years. But this one typical value, this seems to be so odd. It's actually too big or too high from what we have been experiencing in this company. So an average can actually give you that insight, give you your mind to be alarmed that this is too much. It's not actually usual. So it can tell you that, is this normal? This is not normal. That is typical, normal. Yeah, stats normal. Let me just use normal in a normal sense. Is it the usual thing that we usually expect? Is it the expected thing that we usually get? So an average actually helps you. It gives you a central or balance point for the data that we always get something around this point. So that is what arithmetic mean actually tells you. But one thing that I want you to realize here is this. If you have data, I gave you an example here. I'm not sure if you noticed. I gave you this example whereby I have 1, 2, 3, 4, and then you have 100. When you look at 22, 22 is actually way far from these points 1, 2, 3. Why is that so? It's because this 100 is actually pulling this mean towards it, because this one value is actually so large compared to the other values. So it's actually pulling this center. It's actually pulling this center towards it. In other words, this actually value here is not clearly giving us the clear picture of what this data is about, because these values are way too far from this. Even this one is way too far, because this one is actually pulling. It is pulling towards it. So I hope you can see that that one value is actually affecting this mean to actually move so away from so many values. So to say I'm gonna use the mean alone to determine if the center or this data is around this point, it's not always 100% to say I'm just gonna use this one, because in cases whereby one value is so high, or one value, there's this one value that's just an outlier that is just down there and the others are somewhere there, then the mean cannot alone tell you the clear picture of what this data is telling you. That is why when we are describing the center or the central or the balance point for the data, we also need to actually think in terms of the median. I hope this makes sense, because when it comes to the mean, it is affected by values that are so large or by the values that are so small. So we need to also check other point that is not going to be affected by large values or too small values. So that is why we have to talk about the median. Median is also as a measure of central tendency, because the median is actually telling us about the value that is in the middle position. That value that is in the middle position is not going to be affected if I have too large value or too small value. It's just going to be sitting there, picking that value that is at the center, which is actually now giving us an extra information when the mean is actually failing us. I hope you get that. Now let's look into the mean, the median, which is also another measure of central tendency. Median is the value that so you have this data that you have, and then you arrange it into a particular order, from small to the largest or from the largest to the smallest. You arrange it in ascending or descending order. And then what a mean is actually does, or what is the mean? It is the value that divides the ordered data into two equal halves. So the mean is going to divide this data into two equal parts. In other words, on the left, the number of the number of observations on the left, they must be the same as the number of observations on the right. That is what the median is actually doing. It's cutting the data into half. I hope that makes sense. That's what I'm trying to mean by these two positions here. As an example, suppose I have this data here. This one is actually the marks by 7 students: 45, 62, 55, 71, 48, and 80, and 60. Determine the median test score. First, we need to arrange this data from smallest to largest, or from largest to smallest. Here, I've just decided to arrange them from smallest to largest. And then, the next thing is going to say, okay, how many of these observations that I have? I have 1, 2, 3, 4, 5, 6, 7. I have 7 of them. So if I place 3 on the left, 3 on the right, this one value that is in the middle is supposed to be the median, as you can see here. 45, 48, 55, 80, 71, 60. Then this one here is the one that is sitting in the middle. Hence, it is the median. I hope this makes sense. That even if, let's say, I were to change this 80 here and say it is a 1000, then the median will still be the same. It's going to be 60. It's fixed there. That 60 is actually the middle. The middle observation, or the middle value. It's not going to change. But if we were to think in terms of the mean, placing a 1000 here, the mean will change, which means the mean is affected by large values because it needs every single value to participate in order for it to be found. Every single observation must participate in the calculations. But when it comes to the median, we are only focusing on the middle position, middle values, middle observations, middle part. So not everything is going to participate. So the median is not going to be affected by so large values. Hence, it is so useful for us to actually deal with the median and the mean and the median to get a proper distribution of our data. So the mean and the median, they actually give us more information than just the mean alone. Give us a better distribution of the data. It tells us more about the distribution. How is this data distributed? Let's take another example. A question is saying a shop recorded the following sales amount over 6 days. You have 850, you have 1200, you have 950, you have 1000, and this 700, and so forth. Find the median daily sales amount. First, we arrange this data in ascending order, or from smallest to largest. After that, you notice that there are 6 of these things. 1, 2, 3, 4, 5, 6. So there are 2 middle values here. Because let's just for a moment. Look at this. This one. 1, 2. I'm just gonna highlight these 2. I have 1, 2. I have 1, 2 on the other side. Now, where is the median? Remember, the median, we said that the median, it is actually this is what we said. It is the middle position. It is the value that is sitting in the middle. But now when you look into this one, we have 2 of these things. So whenever we have even number of observations, what we do, we take the arithmetic mean. In other words, we add these 2 things and then divide by 2 to get the median. I hope this makes sense. Take this and that, and then you get the median. Because if, let's say, you just place something, the median is just in between these 2. So that we have 3 this side and also we have 3 that side, right? Because it divides data into 2 equal halves. So we want the value that divides. So we can see that we have 2 and we have 2, but we have 2. Which one is it? Because the median must be 1. So what we actually do, we just take those 2, divide by 2, we get the median. I hope this makes sense also. These are some of the questions that I would say just pause the video and then do them and see if you're getting something. And then after you have done them, then you can check these answers here, because I've just have done them. As you can see, when it comes to this one, I've arranged the data, and then after arranging them, I realized that I have 9 values. Then the middle is the fifth, so I have 1, 2, 3, 4. Then the fifth is going to be 28. That is going to be our median. And then the second one, we do it like this because we have 8 values, which is even, so we want to have 4, 4. Then the one that's supposed to be the median is supposed to be between 4th and the 5th value. Hence we add them and divide by 2, we get those customers. That is the median. I hope you can get this thing right. It's not hard. What is important now, in our next class, what we're gonna do, we'll look at the mode, we'll look at the range, quotiles, and and the other things. Because the most important thing that I want you to actually understand here is that you are not actually only focusing on the median. You know how to calculate the median. You are not actually focusing on the mean. You know how to calculate the mean. You are actually focusing on why this mean. Why would you actually calculate this mean? So that when you go out there, at least you know that, okay, in order for me to report on this, let me just look at the averages. In order for me to do this, let me look at the average and the median and then go and give a report. Because the report is not just going to be the bunch of numbers that, hey, we've been doing this and this. Just give them an average, which is usually good estimate. Some cases, just go and do that. Now, like I said, why study the median when you already have the mean? Suppose an auditor examines these invoice amounts. You have 1,000, you have 2,000, you have 1.5, you have 1,800, you have 2,000, you have 2,500, and then you have 50,000. Now, let us first look at the mean. Let's look at the mean first, and then I will explain what this thing is actually saying. Let's calculate the mean. The mean is going to be 1,000 plus 1,200 plus, and then you have 1,500, and then plus, and then you have 1,800, right? And then you have 2,000, and then what do you have? And then you have 2,500, 2,500, and then you have that 50,000, right? And then how many of these observations? 1, 2, 3, 4, 5, 6, 7. So we have 7 of these things. Now take a look. What are we actually doing here? No, this is not 5,000. It's supposed to be 50,000. Yeah. Now we have 8,571. I want you to take a look into this. If you look at this 8,581, is it closer to 1,000? No. 2,000? No. 1,500? No. 1,800? No. 2,000? It is far. And at the same time, it is far from 50. So, what we are, yes, comparing the distance from 50 and 2.5, you can see it is a little bit closer to 2.5. But when you look at this, it is so far from all the values of this data. What is actually happening here? If I were to take, let me look into this. Let me multiply this by 0. If let's say I'm looking at the averages of only this data, excluding this 50,000, the average or the mean will be 1,400 and something. But now that I have this 50,000, just 50,000 there, I'm actually getting the number that is way too above 1.4, which means this 50,000 is actually pulling the mean, closer to these big values, making it larger. So this mean is actually affected by this 50,000. It's actually moving way too far. In other words, this 50,000 here 50,000 invoice is extremely large compared with the other values or with the other invoices. So it is too large. But now when you started to look at the median, you find out that the median is just, you arrange these things and then you find out that the median is 1,800. What does that tells you as an auditor? It tells the auditor the middle invoice is this. The mean, however, is actually much more higher because of this 50,000 invoice. Because this 50,000 is pulling it towards itself. It pulls it upward, making it larger. So the auditor might ask, why is this 50,000 so different from the normal transaction? That could lead to further investigation because now you can actually start to sense it. In other words, let me say it like this. Now that the median and the mean are actually so different, because this is 8,000 and the median is 1,800. These two are different. This simply tells you that, okay, this data that you have is not fairly or well distributed. That's how I want to put it. The median and the mean, they are different, so it is not distributed well. In matter of fact, because the mean is way too far from the median, we can think of this 50,000 as an outlier in the data. If let's say you haven't found, you don't have the data, you're not seeing the data, but by just seeing the mean and the median too different, then it tells you that this data is not well distributed. It has an outlier. I hope that makes sense. And this 50,000 is actually not a typical invoice or a typical value or just usual value in the data. That's what we actually get here by having this being different to the mean. Now, the key points is, if we're talking about the mean, we're talking about the point of balance, where the data would balance if I were to put equal weights, or that point whereby the distance, if I sum the distance from all the other points to that point, they should be equal to the sum of the distance from that point to the other data on the right, if these things are placed on the number line. So it's all about balance. Median, middle position, and this one, mean, is affected by large values or too small values. Too large or too small values is affected, but the median is just sitting there. It's not going anywhere. Now, another examples will be the median. It helps identify the middle of a data set. What is the middle position? The median tells you the value that sits at the middle position when the data is arranged from smallest to the largest. That's what it does. That's what it helps you. It is also useful when there are extreme values. Consider salaries of 5 employees. You have 8,000, you have 9,000, you have 10,000, you have 11,000, and then you have 100,000. So the 100,000 salary pulls the mean upwards significantly, while the median remains at 10,000. This can give a better idea of what a typical employee earns, an average employee earns. Because by just saying, let's say now, let me write this. So you have 8,000, I'm calculating the mean here, plus 9,000, plus 10,000, 1, 2, 3, plus 11,000, 1, 2, 3, plus 100,000, 1, 2, 3, 100, 1, 2, 3, and then divide how many of these? 1, 2, 3, 4, 5. We have 5 of these things. The mean average 27,000. If you look at this 27,000, this employee, that employee, and that employee, and that employee, they are not earning. This is about double. This is more than the double of the salary of all these employees except this one. Now, by having the median and the mean, it tells you that there is this employee that is earning way too more compared to the other employees. So we cannot say as a company that on average we are earning around 27,000. That wouldn't be fair because so many other employees, they are earning way too less than this. So having the median and the mean, it gives you a better idea of what a typical employee earns, because the median, the one who's just in the median, is 10,000, which is less than half of this. So which means one of these higher values or higher salaries is an outlier. It falls outside this normal data that we have, this normal salary of the other employees. This one is just one of these greedy individuals that is actually deciding to be the only one who's getting. Because now when we're using the mean alone, it's not going to be actually giving us the whole picture. But the median, it helps us to get a clear how is this salary actually distributed. Because the mean alone is actually affected by too big or too small values. I hope this makes sense. And then the median, it helps auditors understand financial data. An auditor can use the median to examine things such as typical transaction values, expenses, salaries, customers' purchases, or invoice amounts without allowing few unusual large transactions or too small to dominate the picture. So this median is actually putting more balance into our understanding that, because we know that once we have this mean, if we're using the mean alone, what if we have a too large value here? We're not going to get a correct or a clear picture of what is happening. But once we have the median here, it actually pulls you back to reality that actually the middle number here, or the middle transaction, or the middle salary, or the a typical expense, or a typical salary, or a typical customer purchase is this much. So it helps us so that we are not blinded by these too large transactions. I hope this makes sense, that median also help us to get a better understanding of the financial data. Another example is it can help identify unusual transaction. Okay, too large and too small. I hope that one it also make perfect sense. And other examples would be, it is useful for school data. You find out sometimes you have large data, and then you have few of these too large, or you have few of these too small. So it also gives you that picture of where is this data skewed. As like, do we have so many numbers very low, or do we have so many numbers very large, or are we actually having a balanced data? So it actually gives us this skewness of the data, the median, help us balance us there. And it's also it is also useful in everyday financial decisions. If you are looking at house prices, salaries, rent, or household expenses, the median can give you a better idea of what a typical person or household expenses when a few very large values exist. So it also balances us there. So it helps you compare the mean and median. So once you have the mean and the median, comparing the two can tell you something about the distribution of the data. If the mean and median are very different, that may indicate that some unusual high or low values are affecting the data. So once they are too different or very different, then we know that there are high values or too low values that are affecting our data. And if the mean, they are closely the same, or they are very similar, like if you, let's say the median is 1000, let's say the median is 1200, and then maybe the mean is around 1250 or something close to that, then this often suggests that the data is fairly symmetric around the center. In other words, all the data points are not too far from the center, or from the middle point, or from the central position. They are not too far. So it is symmetric. It is close to the center. Can I find something? Let me check if I can find something to say what I'm trying to symmetric. can I do? Uh, when we're talking about symmetric here, it means that all the data points are actually um, distributed well around the central position. If there is a data, let's say this is the mean or the median, you can see that all the data is distributed well, both on the right, both on the left. It's just distributed well around this middle position. That's what we mean by having this thing. So the data is not scattered all over. It's not scattered all over. It is like this one here. Look at this. The data is actually closer to the mean if the median and the mean, they are approximately the same. Suggests that the data is fairly symmetric around the center. The data is distributed well around the center, so you don't have that one value that is so high or too slow, too small. All these values are actually of closely similar distance from the mean. I hope that makes sense. From the center, when this mean and the median are closely the same or the same, the data is distributed well. It is if you check at the points, let's say you check the points on the left, you find out, if you look at these distances from this center, you find out there is also almost the same number of data points on the right that are of equal distance from that center. Does that make sense? I hope so. Now, when the mean and median are different, this suggests that the data is not perfectly symmetric. It is not distributed well about the center. There are few data points pulling the mean either up or down. So there are few data points pulling the mean either up or down. When there is a large difference between the mean and the median, this is particularly interesting. A large difference may indicate that the data contains extreme values, which means there are so many outliers. I mean, there are outliers, right? There is strong skewness. In other words, the data is either it is more skewed to the left or pushed to the left, but it is very uneven. Like that example when we had 1, 2, 3, 4, and then we have that 100 there. That one, when you check the mean and you check the median, you find out the median is very, very, very low compared to the median. The median is actually very low compared to the mean. So that particular example is the one whereby we're actually seeing this example of 100 being an extreme big value, an outlier from this data 1, 2, 3, 4. I hope this makes sense. I'm gonna stop there. In our next class, I want us to look at the mode and other thing. Mode is gonna be mode. It's going to be the range. It's going to be quartiles. It's going to be other things. But I wanted us to focus on these two. Of course, when we're doing those other things, we're gonna be too fast. What is the range calculated? I was just trying to give a clear picture on these two, how they actually help us. And then we're gonna see us trying to explain when we are getting to the variance and the standard deviation, whereby we're actually explaining more why is this useful, because these two, they actually tells you about the center of the data. Of course, when you actually look at the median and now you look at the quartiles, they actually kind of play a very similar role. So I'm not gonna get into explaining those things. We're just gonna calculate them. I might just explain in 2 or 3 points on mode, and then we'll focus more when we start to do now standard deviations and variance and all those things, whereby we'll talk about more explanations because of time. Some other things we're just going to look at calculations. These were of particular importance. Thank you very much. Please try and understand and grasp this information and try to calculate and make sure that you understand the meaning of the mean and the median and why they are useful, because those things that will help you a lot when you are actually getting out there and actually doing the actual work. Thank you.